On the third page of your notes, you have a mole map already drawn there for you. So I wanted to review how to use this, and then you're going to keep your mole map handy either on your notes or on your little note card while we work through the notes today. So the first thing that you need to remember is that you will always start in the given substance. So I wrote that kind of big, but I want you to note that. So you will always start in your given substance. I'll make a little ugly little cloud around that. Always start in your given substance. And then there are multiple places that you can start based on whatever your given is. So you could start in grams. So I'm going to put G and then put that in a box. You could also start in what? Moles. That's kind of our like central point. Moles. You could also start in what? There are three things that we put kind of tiered together. Atoms, or there are molecules, or there are formula units. I know I didn't make those evenly spaced, but we get it. Then I'm going to zoom in a little extra small to leave space to write that we are now going to break down molecules into, I'm going to give myself more space than this. I'm going to put molecules and formula units. So I only erased it to give myself more space to write. Molecules are going to break down into atoms. So that's another place we can go. And then formula units will break down into ions. The only difference between the two is that a formula unit is ionic. That's why it breaks down into ions. Ions have charges. A molecule is covalent. Your atoms don't have charges. These are just your single elements. And then we'll talk about kind of where you use each of these. But they are all going to be on the same level here. Where if you are using this conversion or this one, the number that you will use is the definition of a mole, which is that 1 mole is equal to 6.02 times 10 to the 23rd of any of those things. So I'm going to put things. I don't remember exactly what we wrote in your notes. Did we say things there? Yes? Okay. So what that means is that when you use this as a conversion factor, what actually shows up in your T-chart is 6.02 times 10 to the 23rd atoms, or 6.02 times 10 to the 23rd molecules, or 6.02 times 10 to the 23rd formula units. And what goes next to moles is the number 1 every single time, because the definition of mole is that many things. So it doesn't matter what unit comes after it. It's going to be that many. To determine which one of those things you go to, you just have to figure out what your substance actually is. And then between grams and moles, our conversion factor here is called molar mass. Molar mass is always 1 mole. And then the number of grams comes from where?
Periodic table.
Perfect. So from the periodic table. So I'm going to zoom that out. And basically, this is half of our mole map because this is in our given substance. I don't like the way that the little thing looks right now. Okay, get rid of that. So given substance, and that is where we are. So all of this is talking about my starting substance. Then I'm going to change colors just to show you can also change substances. And so basically this is the difference between stoichiometry that we're doing this term versus just regular dimensional analysis that we did last semester, is if you are changing substances, I'm going to say new substance, and give an exclamation point there, you have the same map between grams and moles and each of your particles, atoms, molecules, formula units. And then same thing there, your molecules can break down into atoms, and your formula units can break down into ions. All of these are the same. It just depends on what the question is asking you for, where you're going to end up. But I always draw it twice, that way you can see where you're supposed to end up going. The important part is that the only conversion between these two maps, the only way to get from your given substance, I'm going to use a different color to highlight this. The only way to get from your given substance into a new substance is through the conversion factor between moles. You can only connect at moles. And so when I was walking around before, I saw several of your papers where you had lines between grams and grams, or you had lines over here on particles, and that is not correct. You can only convert between two different substances through moles. So I'm going to unhighlight that so that we can actually read it better. Okay. So from moles of one thing to moles of another, what do you have on your notes? What is our conversion factor here? Do you remember? How do you get from moles of one thing into moles of another?
By using the coefficients.
Coefficients, perfect. So this is where you should write coefficients. This comes from your balanced chemical equation. So this, you have to have an actual equation to use. The coefficients are the only time that you may or may not have a coefficient of 1, in front of moles, I mean. So in front of moles, anywhere else in our chart, here, molar mass is always 1 mole. Up here, 1 mole is always equal to that many things. So either way, you're putting a 1 next to moles. Typically, that's what you'll see. In front of the coefficients, though, when you're determining how many moles something has, you use the coefficient. Sometimes it's 1, sometimes it's not. But that's where your balancing comes into play. So keeping this in mind, I know that's kind of messy, but we spent a lot of time doing the mole map before, so I'm going to move on. Give you time to copy it from your notes. Make sure you have this on your note card. This one says converting between grams and moles, and then atoms or molecules or formula units. So question A says how many AU atoms are in a 25.0 gram pure gold nugget? Sorry, I said that kind of weird, but if my given information is this, pure gold nugget, 25.0 grams. If it is a pure gold nugget, that means that it's just AU as my substance. So I have 25.0 grams of AU, gold. So if I look at my mole map, I'm starting right here in grams of my given substance. Then I look at what I'm looking for. It says how many AU atoms. So I need to go from grams to atoms. But I have atoms here, and I have atoms here, and I have atoms here and here. How do I know which one I'm going to? Or does it matter? So look at the substance that we started in. My starting substance was pure gold. It tells me that right here. So that's why I called it AU. I'm looking for atoms of AU. So do I change substances at all? If my given information is gold and my final information is also gold,
No.
I'm not changing substances, right? So that rules out this part. That means I'm not going to be using the coefficients in a balanced chemical equation. Also, a dead giveaway should be that there is no chemical equation given in that question, so that's not relevant at all. And then if I'm going to this type of atoms, that means I'm breaking down a molecule to turn it into atoms. But gold is not a molecule. Gold is just an atom on its own. So that means I can go directly from moles into atoms of gold. Make sense? Okay, just like I stressed last time, your mole map, I know mine is already getting crazy out of control with how messy it is. I'll pull up a cleaner one for the next question. It is only as helpful as you allow it to be. And so you will have this resource on your test, but if you don't practice with it, it's not going to make any sense to you. So I'm going to go from grams into moles, and then from moles into what? Into atoms. Good. So I have mapped out my path here. So I'm going to go grams. I'll bring grams of gold down to the bottom. I brought that down so that it would cancel. So once my grams cancels out, I am in my new unit, or new substance, new unit, moles of AU. Whatever I bring up top, I have to put at the bottom if I want it to cancel. So I'd put moles of AU at the bottom. That ends up canceling out, and then once I'm done with moles, I go into atoms. So atoms AU. The moles cancels, and then between grams and moles, my conversion factor is called what? Molar mass, which we wrote is always 1 mole. So 1 mole is equivalent to the number of grams from our periodic table of gold. Gold is here on our periodic table. 196.97, if I can highlight it. Oops. Okay. 196.97. And then between moles and atoms, that's where we use Avogadro's number. So 1 mole is equivalent to that many things. So that many atoms in this case. 1 mole equals 6.02 times 10 to the 23rd atoms. Then I'm going to multiply everything on top. So what you're typing into your calculator is 25.0 times 1 times 6.02 times 10 to the 23rd. Remember to type this in the correct way on your calculator. You're not actually using the multiply button there. And then you divide by everything on bottom. So in this case, you're going to divide by 196.97 and then divide by 1. Or really your ones would cancel, and also many of you already understand that the ones aren't going to change your answer. So when you type this one into your calculator, I'm going to try to hold this in front of you here, that way you can see what's happening. I have 25 grams of gold. I'm going to multiply that by 6.02. On this specific calculator, instead of typing times 10 to the power of 23, you type second, comma, and so the comma is this button right here. And then what that puts on your screen is the E. And then you type 23. Then when I get to the end of the numerator, I usually just hit enter, and then you'll divide by everything on the bottom. So 196.97, and then you'll hit enter again. And this is the number that I calculated. So 7.64, that E22 at the end means times 10 to the power of 22. So real quick, I'm going to show you in the Casio calculators as well how to type that exact same thing. So if this is the calculator that you have, so this is the majority of calculators in my classroom, this is 25 grams of gold times 6.02. Then you'll hit shift, which is that top left corner. And then on this calculator, you press log. So what shows up on your screen is this. And then 23. Then you'll hit enter. And then divide by 196.97. Then you'll hit enter again. And you get the exact same number. It just shows up a little bit differently. So don't forget to include the times 10 to the power of 22 at the end. So our answer is 7.64 times 10 to the 22nd power. So I'm going to turn that off. Go back to this. Sorry, 22nd power. Did I say 20? So 7.64 times 10 to the 22nd power. And then the unit is atoms of gold, AU. Good? Any questions on that one before we move on? If you just wrote 7.64, that is not correct. That times 10 to the 22nd is really important.
What do you count
Yes, absolutely.
You wouldn't even give us like a little.
No, no partial credit because it's completely the wrong number. Because something else that happens is if you do not type this into your calculator the correct way, if you use the wrong button, so for example, on your TI calculators, so I'll pull this back up. On the TI calculator, a lot of students keep trying to use this button. So this is what I was trying to show you a little bit earlier. They keep trying to use this log button that has the 10x on there. It looks like it would be the correct button to use, but this does not calculate the right answer. And so a lot of times you'll end up with almost the same like base number, but then the times 10 to the power of whatever is way, way, way off. And that's one of the ways I can tell how you typed it in. So we'll do an example with that one as well. So then let's jump down a little bit. I want to do one from each section just to make sure that we get through everything today. And then we can go back in and fill everything out as we go. So this Roman numeral 2 says converting grams to moles to molecules to atoms. Where this ends up confusing students is that I think you're overthinking what this actually means, or maybe you're just not super familiar with the vocabulary. So I like to start with the ratio first. So I'm going to fold this down. The ratio of what is given to you in your formula. So this question says how many atoms of oxygen are in this many grams of H2O? So you're looking for atoms. You know that when you're done with your whole question, if you recognize that you will be in atoms of what when you're done? Atoms of oxygen, which is just O. So atoms of oxygen is what we're looking for, and our given information is 67.8 grams of H2O. There's no such thing as going to atoms of water because water is not an atom. What type of particle is water? So when I say particle, the particle level on our mole map is like this level right here. So these are all things that we call particles. So atoms, molecules, or formula units. What is water, H2O? It is a molecule. So if you are going to go into particles of water, you are going to go into molecules of water because water is a molecule. But what this question is asking us to do is further break down water into the specific atoms that make it up. So we are given information on water in grams. So we are starting in grams of my given substance. I keep highlighting these and then wanting to erase it to make it look not so terrible. Okay, let's put atoms back. So if we're starting in grams of H2O, then we're definitely going to go to where next? The only place you can go from grams of H2O. To moles of H2O. So it's going to say moles of H2O. From moles of H2O, I can either break that down into molecules of H2O, or I can change substances using the coefficients from my balanced chemical equation. In this question, I don't have a balanced chemical equation, so again, that's another sign that that's not what you're doing. So here, you are actually going to go from moles of H2O into molecules of H2O. I made that double-sided, but you're only going the one direction. And then from molecules of H2O, you're going to further break that down into atoms of oxygen. So does the map part make sense so far, at least our route that we're taking? Yes? If it doesn't, stop me and I'll slow down. Or explain it differently. Alright, so let's start with the question. Are you good here so far? You understand how we got this stuff? So let's draw our line and just take it one step at a time. Grams of H2O is going to come to the bottom. So at first glance, it might look like the substance that we are using, or substance that we are starting with, is not the same as the substance that we're ending with. But if you actually understand what this question is asking, it's basically asking us to break down water into the atoms that make it up. So I'm going to write a ratio for us. So for every one molecule, since we identified that water is a molecule, so for every one molecule of H2O, how many atoms of oxygen are in one molecule of H2O? 1. I get that number from the subscripts. There is no subscript on oxygen, which tells me that there's just one of them. What if I asked you how many atoms of hydrogen? Then it's 2, because there's a subscript of 2, so that tells me there are 2 hydrogens per molecule of H2O. So I'm going to use this ratio. So this question is asking about oxygen, so I'm going to keep O. There is only 1 atom of oxygen per molecule of H2O. That's all we're doing to convert between this part and this part. So to get from molecules to atoms, that is what we're using, is the actual formula ratio. So from grams of H2O, we've already identified on our mole map, even if you don't know where you're going next, the only place that you can ever go from grams is into what? Moles of the exact same substance. So I'm going to go from grams of H2O into moles of H2O. If I have moles of H2O up top, I also need to bring it diagonal down. So I'm going to bring moles of H2O to the bottom. So now I'm in moles of H2O. I can break this down into how many molecules of H2O and then go from molecules into atoms, which is what the question is asking me for. So I can go from moles into what? Molecules of H2O. And then I can bring molecules of H2O to the bottom. And then what would go on top? Atoms of oxygen. So my grams of H2O cancels with grams of H2O. Moles cancels with moles. Molecules cancels with molecules. And then I'm left with atoms, which is what I'm looking for. So that's when I stop. And then we go fill in our conversion factors. So between grams and moles, according to your mole map, what is the conversion factor that we put here? Molar mass, which is always 1 mole. And the number of grams comes from our periodic table. So we're going to calculate the molar mass of water.
18.015.
All right, y'all are fast. So 18.015 grams of H2O. Between molecules and moles, my conversion factor, so I'm going from moles to molecules, so that's this line right here. What is our conversion factor? You have the right idea, but the number you said was a little bit off. 6 point. Oh, they said 212. Oh, 6.02. Yes, sorry. 6.02 times 10 to the 23rd. So that number is Avogadro's number. That goes in front of what unit? Yes. So 6.02 times 10 to the 23rd. Molecules. How many moles is that equivalent to? Just 1. And then to go from molecules to atoms, this is the conversion factor that we basically made up by looking at the formula. So 1 molecule of H2O has how many atoms of H2O? 1. So that's not going to change your number at all, but you will still get points for showing me that step in your process. And sometimes it's not going to be a 1-to-1 ratio. So then let's multiply this. I'll flip my screen again. That way I can show you what I'm typing in on the calculator. I'm going to use the Casio calculator for this one, just because that's what most people have in here. So first, starting with, it was 67.8, right? 67.8 grams of H2O times 6.02 Now you can't really see what I'm typing down there. All right, 6.02, and then on this one you use shift log, and then you have the 10 show up on your screen. Notice there's no multiply symbol. We are also not using the caret button at all. And then you type 23 for your exponent, and then at the very end you would multiply that by 1. That gives you this. And then I would divide by 18.015, and I got this. Is that what y'all got? Perfect. Do you want me to show you on the other calculator, or you're good?
You should show it for the calculator.
Show it on the other one? Alright, so this one shows up like that on the other calculator. Same exact numbers that we're using, of course. So 67.8 times 6.02, and then we use second, and then the comma button right here. So what shows up on your screen is 6.02e, and then 23. Then you multiply that by 1, and then divided by 18.015. You would also, I guess, technically divide that by 1, but of course dividing by 1 doesn't change your answer, and neither does multiplying by 1. So same exact answer in both of my calculators as long as you typed it in this way. If you used a different calculator and you got a different answer, that means that you are not using the correct buttons to type this in. So when you write this on your paper, you can go ahead and round to 2 decimal places, but just don't forget the scientific notation part at the end, the times 10 to the 24th. So I'm going to flip the camera back and go to this, and we'll say 2.27 times 10, get that out of the way, to the 24th power atoms of oxygen. Do you what? Yes, unless you want to write all of those decimal places, I guess you can do that. But no, I mean, on your test, you would at least have to recognize the number of decimal places that it's rounded to, and typically that's 2 decimal places. All right, let's jump down to the third section. So I did one example from section 1, one example from section 2, and then I want to do an example from section 3, and then we'll go back through and kind of fill in more of our blanks. So this is when we're converting from grams to particles of different substances within a reaction. So first of all, you'll notice that right away we're starting with a chemical reaction, which is different than the first 2 sections of these notes. It says how many grams of magnesium are needed to produce 8.07 times 10 to the 28th molecules of H2. So let's first start by balancing our equation that's not already balanced for us. I have 2 hydrogen atoms on my product side and 2 chlorine atoms on my product side, so I know that at least I'm going to want 2 of them on my reactant side, so I'm going to just start with the coefficient of 2. And then once you have 2 HCl, everything else is already balanced. So what would go in the other blanks? Just 1s. Perfect. And then based on the question, it says how many grams of magnesium. So if you look at this, and even if you don't know where you're going from the very beginning, if you can show me that you know your final answer is going to be in grams of magnesium, you can put equals blank grams of magnesium. That shows me that you understand what the question is even asking you for. So when you put that on your paper, already you've earned yourself at least 1 point, plus however many points the balancing equation is going to get you. Then the other thing that most of you are really good at identifying is your given information. So that includes a number, a unit, and a substance every single time. So what is our given information here? .07 times 10 to the 28th. Okay, 8.07 times 10 to the 28th. What is our unit?
H2.
The correct substance is H2, yes. So we are in H2. What H2 though? Molecules of H2. So this many molecules of H2. The abbreviation for molecules, remember, is MC. You can write out molecules if you want, but it would just obviously take a lot of space. Do not abbreviate molecules as MOL because MOL is already the abbreviation for moles, and that's not the same thing. So we use them differently. So moles is MOL, MC is molecules, so that you don't get them mixed up. So molecules, and our substance is H2. And you draw your line. So already, just from our T-chart and not even considering the balanced chemical equation, I'm pretty sure on your test, your equations are maybe already balanced for you because I wanted to see your stoichiometry and not your balancing stuff. But already this would be 1 point for your given number, 1 point for your given unit and substance, and 1 point for your final unit. So that's 3 points without really even starting the question. Then you can earn yourself another point because you know automatically if you start in a certain unit, what are you going to do with that unit in your T-chart? Bring it down. So you're going to drop down your unit of molecules of H2. Why do we do that every time?
Cancel out.
Perfect. So this is going to cancel out, which means I need to go to a different unit. So I'm going to go back to my mole map. I'm going to erase the little scratchy stuff from before. So I am starting in my given substance, of course. I'm always starting in whatever my given substance is. And I am starting in molecules of my given. The question is asking me for grams of magnesium. So if I'm looking at this, I need to go from molecules to grams. Now grams shows up twice on this mole map.
Just go back.
What? Yes, you can keep going. Like all of these arrows, notice, are double-sided, so you can go both directions. But it's about which grams am I going to. So molecules is right here. I'm definitely in my given substance because that's what I started with always. But am I going to grams of my given substance or am I going to grams of a different substance? Grams of a different substance. So this is exactly why we call this the mole map, because you will use this to route yourself to where you're going. So we need to get from molecules of my given substance into grams of a different thing. So I'm going to go molecules to moles. Then I'm going to go from moles to moles. And then I'm going to go from moles to grams. So you see this path we're taking? Nods, shake your head if no. Okay. So from molecules, where am I going first? Moles of my same substance. I'm going to put moles of H2 on the top. I'm going to bring moles of H2 to the bottom. I do that so that it will cancel out. Okay, then moles of H2 cancels, and then I go to moles of a different substance. So in this case, it would be what?
Magnesium.
Good. Okay, so moles of magnesium. Then I go from moles of magnesium into grams of magnesium. So I'm going to bring moles of magnesium down to the bottom and grams of magnesium at the top. I'm going to cancel out moles of magnesium. And then I go and I fill in all my conversion factors. So looking at your mole map, between moles of H2 and molecules of H2, my conversion factor is Avogadro's number. 1 mole is equivalent to how many molecules?
0.02
Perfect. Then between moles of magnesium and moles of H2, this is the only part where you will maybe have a number that's not 1 next to moles. We use the mole ratio coming from the coefficients in our balanced chemical equation. So here, my coefficient in front of magnesium is 1, and my coefficient in front of H2 is also 1, so it's just a 1-to-1 ratio. And then between grams and moles of magnesium, moles to grams or grams to moles is always molar mass. Molar mass is just 1 mole. And the number of grams comes from our periodic table. So for magnesium, that's going to be 24.305. And then we're going to type all of this into our calculators. So setting this up again to show you what we're calculating. So that's from the previous calculation. I'm going to use the graphing calculator first. So typing in 8.07, and then I use second, comma, so shift log on the other calculator, 28. 8.07 times 10 to the 28th, and then I multiply that by the molar mass of magnesium, which is 24.305. Here's what I have. And then I hit enter at the end of my numerator, and then I divide by 6.02, shift log 23. You would divide by 1 also, or don't actually have to type that in because it's not going to change my answer. So I got a really, really long number. Is that what y'all got? Look at the clapping.
Round of applause for our sweetie bits.
This is a little bit absurd, but we'll go ahead and write it anyway. Yes, the whole thing. So, back to our answer. It is a ton of grams. So 3258161. 3258161.96. So boom, boom, boom. So it's 3,258,161.96 grams. That's a lot. All right, we will stop there for now, but we'll come back to this later.